Alright, 7.4, we're going to be looking at the inverse of trig functions. In order to help you better understand, I have gone to the textbook. This is page 524. They show you several graphs of what the inverse functions look like, but for all intensive purposes, we really need the functions and the domains and ranges. Mainly the range is going to help us. So for inverse sine, also known as arc sine, the range, the y values that we're looking at are between a negative pi over 2 and pi over 2, including it because it has square bracket. With cosine, it is 0 to pi, and with tangent, it is from negative 2 pi to pi, and the endpoints are not included here. Alright, so we're going to be using these restrictions to solve the problem. So just keep note of that. And also we're going to be using, I've looked up online a unit circle. This is from a website called Embedded Math. But all I did was Google search unit circle PDF. And I think it was like the second link. Let me, actually, I can't go back because I closed it already. But this is like the best one I've seen. It shows you all the degree measurements around up to 360. It shows you all the radian measurements all the way up to 2 pi, the full circle. You have all the ordered pairs listed around. You even have this outlay that shows you where each of the trig functions are positive and negative. And it has it color coded so you can kind of see black positive, red negative. So this is like one of the best ones I've seen. I hadn't seen anyone better than that. But we're going to be using this unit circle to answer these questions. And once you get the pattern, it's not so bad. So for number 1, we want to find the inverse sine of negative 1. Alright, so we're going to find sine represents the y values. Okay, so since it's inverse, we're looking at the ordered pair. So if I go to this unit circle, I'm looking for negative 1 in the ordered pairs. So if you imagine that this is an x and y axis in the middle, the 1, 0, 0, 1s are all on the outside. Well, the one that gives me a negative 1 for the y value is down here. And that corresponds to two measurements, 3 pi over 2 and 270. Those are the degree and the radian measure. 270, 3 pi over 2. Okay, so I'm going to write those down. 270 degrees and 3 pi over 2. Alright, so these will be my two angles from the y value. But we got to remember that the restriction said that this guy has to be between pi over 2 and negative pi over 2 and pi over 2. Alright, in degrees that represents negative 90 to 90. Alright, so let me go back to this circle one more time and give you a visual. What are they saying? What is this restriction? So if you look at starting here, you start at 0, going all the way up to the vertical line. This is pi over 2. That's 90 degrees. So it's saying from here up, and then if you were to go backwards instead of going clockwise all the way around, if you start at 0 and go backwards, this area down here would represent negative pi over 2. Well, how do you actually see that, or how would you transform these numbers? You do that by subtracting the unit of full circle, which is 360, subtract the degrees from that degree, and that will keep you in this area. With 2 pi, or the radians, you would subtract 2 pi from the radian measure to get within those limits. I don't think they explain that in the text, but that's something you kind of pick up on. So if I want to be within the restrictions with this angle, I have to subtract 360. That's the same as going backwards. Or you can find the distance it is from 360 and go negative. But subtract 360, that's the math behind it. And if you do this, that actually gives you negative 90 degrees. It's right on that vertical axis. So the answer for inverse sine in degrees is negative 1. With the radians, I have to subtract 2 pi. That's a full circle in radians, so minus 2 pi. I got to get a common denominator. So if you think about this over 1 and you multiply top and bottom by 2, then that will give you 2 on the bottom. So I'm going to write one fraction with 2 on the bottom, and then that will give me 3 pi. That one stays unchanged, but 2 times 2 pi will give me 4 pi. And then 3 pi minus 4 pi will give you a negative pi over 2. The bottom will stay the same. Alright, so this is the radian measure, this is the degree measure, and I think they want both here. So the first one says type exact answer using pi as needed. Express your answer in radians. So radians would be the negative pi divided by 2. And then the degree, which we already found, was the 270, but you subtract 360 to be within those limitations, and that gives us negative 90. The degree symbol is there, so you don't need to add it.